Hello everyone, welcome to the map of mathematics. In this video we are going to solve an important mathematics Olympiad problem which is known as homogeneous differential equation problem. So now we move toward the solution of this question. Here we have the differential equation in this form: x cube plus y cube over x square plus y, x square y plus x y square. So here first we will check that is this differential equation is homogeneous or not, and I will explain this concept in the previous lecture. So please watch my previous video, so that's why your concept about homogeneous problem is clear. Now in order to check that this equation is homogeneous or not, so we will check the right hand side is homogeneous or not, and here I can clearly say that the right hand side is a homogeneous function. In the procedure to check the homogeneous function, please watch my previous video. In this video I will explain the method in which you will find the solution of a homogeneous differential equation. The very first step you can do is y is equal to vx. We will substitute in the differential equation as y is equal to vx. Now you can substitute all the homogeneous equation, all the homogeneous problems. First step is y is equal to vx. Okay, after that we will take the derivative of both of the sides and we will obtain dy by dx. So here we apply the product rule first as it is, and the derivative of second dx over dx plus second term is as it is, and we will take the derivative of first term dv over dx. After that this dx is cancelled out and we will obtain v plus x dv over dx, and here we have dy over dx. So this is the equation number 1. We substitute all the values in equation number 1. We can take this equation as 2. We will put the value of equation number 2 and the derivative in equation number 1, and we will obtain the differential equation in this form. When we substitute the value of dy over dx, we will obtain v plus x dv over dx is equal to, here we substitute the value of this derivative, and when we substitute the value of y in the right hand side, we will obtain x cube plus when you substitute y is equal to vx, we obtain v cube into x cube over here we substitute the value of y is vx, and we will obtain x square into v of x plus x into here we put the value y and we will obtain vx square. Okay, after that we take common in the numerator is x cube, and we obtain x cube into 1 plus v cube over we will obtain this one is x square. When this x square is multiplied by this x, it becomes x cube, and also here x square is multiplied by x, this will also becomes x cube, and we take it, this x cube is common, and after that we will find the value of v plus here we remaining value is v, and the remaining value in here is v square. Okay, after that this x cube is cancelled out of each other. So after that we take the term, this term is in the left hand side v is positive, when we take it in the right hand side it will becomes negative, and in the left hand side we will get x times of dv over dx is equal to, here we obtain 1 plus v cube over v plus v square and minus v. Okay, this is the v which we can take from left hand side to right hand side. Okay, and now we will simplify this term, and first we will take the LCM here, and we will simplify this LCM, and we will obtain minus time of v square minus v cube. This v cube is cancelled out of each other, and we will get 1 minus v square over here. We will take common v from both of the terms and we will get v into 1 plus v. And now we know that a square minus b square is equal to a minus b into a plus b. So we can write we can apply this formula here, and we will get 1 minus v into 1 plus v over v times of 1 plus v. This 1 plus v is cancel out here, and we will get x into dv over dx is equal to 1 minus v over v. After this simplification, we will obtain the differential equation in this form, and this form of differential equation is known as the separable differential equation. So here we will write we will separate the variables on both of the sides, and when we will take the variables v in the left hand side, and when you can take the variable in left hand side, we will get v over 1 minus v into dv is equal to 1 over x times of dx. Okay, we will take the integration on both sides, and here you can apply integral on both of the sides. The integrand is improper form, so first we will convert this improper form to proper form. In order to convert this improper form to proper form, we will divide v by 1 minus v, and we will write after division we will write the expression in this form: minus 1 plus 1 over 1 minus v into dv is equal to, here we know that the integration of 1 over x is log of x, and plus we will add log of c be the constant of integration. So after that, here we take integral separate on both of the terms, and we will get minus v and minus log of 1 minus v is equal to log of x plus log of c. Okay, after that we will rearrange the terms, and we will obtain log of c of x into 1 minus v and plus v is equal to 0. Okay, we just rearrange the terms, and we take the term logarithmic terms on left hand side, and after that we apply the properties of logarithm and combine, we will obtain this expression. Okay, after that we will back substitute the value of v. We know that y is equal to vx, and the value of v is y over x. We substitute the value of y v is y over x in this expression, and we will get our final answer in this form: log of x minus y and plus y over x is equal to 0. This is the our final answer, and thank you so much for watching my video.